Hello friends, so here in this problem we have to evaluate limit n tends to infinity 1 square plus 2 square plus 3 square plus so on plus n square. It means we want addition of squares of n terms whole upon n cube. Now if you'll observe the limit, then here we have n tends to infinity, and whenever we have any variable or any limit which tending towards infinity, then that time we substitute that variable or here n as 1 upon t. So before substituting n equals to 1 upon t, if you will observe the numerator, then in numerator we have a series, that is 1 square plus 2 square plus 3 square plus so on till n square. That means the summation of squares of n terms, and we have a formula for the summation of squares of n terms. So first of all, I'll substitute the formula in the numerator, and after that, as we do, we will put n as 1 upon t to evaluate the limit. So first of all, I'm assuming this given question as L. So let L equals to limit n tends to infinity 1 square plus 2 square plus 3 square plus so on till n square whole upon n cube. Now the formula for this series is 1 square plus 2 square plus so on till n square is equal to n into n plus 1 into 2n plus 1 upon 6. So I'll substitute this formula in the numerator. So we'll get L as limit n tends to infinity n, then n plus 1 2n plus 1 upon 6, and in the denominator we have n cube, so it is as it is. Next we'll simplify the terms. So here I'll multiply this bracket with n, and this 6 will go in the denominator. So we'll get limit n tends to infinity. This will become n square plus n. Here we'll get 2n plus 1 upon 6n cube. Next, this will become limit n tends to infinity. If I'll multiply these two brackets, then I'll get n square into 2n, that is 2n cube, then n square into 1, that is plus n square, n into 2n, that is plus 2n square, and n into 1, that is plus n, whole upon 6n cube. Next, so L is equal to limit n tends to infinity. Now what we'll do is we'll divide the each term with 6n cube. So here we'll get 2n cube upon 6n cube as first term, plus n square upon 6n cube plus 2n square upon 6n cube plus n upon 6n cube. And if we'll simplify this, then n cube and n cube cancel. 2 by 6 will become 1 upon 3. So therefore L is equal to limit n tends to infinity. So 1 upon 3 as first term. Then in the second term, this n square and n square from the denominator will be cancelled. So n will remain. So 1 upon 6n in the denominator. Similarly here n square and this n square is cancelled, so 2 upon 6n in the denominator. So from here I am getting 1 upon 6n plus 2 upon 6n. Here n and 1n is cancelled, so 1 upon 6n square will remain. So plus 1 upon 6n square. Now we will substitute. Now since we have simplified the term, here if you'll observe the middle two terms, then here the denominator is same, that is 6n. So here I can write denominator once. So here I'll get L as limit n tends to infinity 1 by 3 as it is plus 6n in the denominator, and in the numerator we'll get 1 plus 2, that is 3, plus 1 upon 6n square. Next, so therefore L will become limit n tends to infinity 1 by 3 plus 1 upon 2n plus 1 upon 6n square. Now after simplification, since we have limit n tends to infinity, we will put n as 1 by t. So here I'll say put n as 1 upon t. So now as we put n equals to 1 by t and n tends to infinity, so here we are gonna get infinity equals to 1 by t, and we all know that whenever we get answer as infinity, so it is possible if the denominator is 0. So it means when t is 0, 1 upon 0 will be infinity. So it means when n tends to infinity or n becomes infinity, that time t becomes 0. So here I'll say as n tends to infinity, t tends to 0. Now as we got n equal to 1 by t, if I'll try to find 1 upon n, that is reciprocal of this term, then here I'll get t. So it means wherever I have n, I'll substitute as 1 by t, and wherever I have 1 upon n, I'll substitute as t. So therefore this L will become limit, now n tends to infinity has become t tends to 0, 1 by 3 will remain as it is, plus 1 by 2. Now here we have 1 upon n, and 1 upon n is t, so I can substitute here it as t. So this term will become t by 2. Similarly here we have 1 upon 6, and we have 1 upon n square term, so 1 upon n square will become t square. So I can substitute this as t square. So we got the term as 1 by 3 plus t by 2 plus t square by 6, and here t tends to 0. So now we got limit as a finite number, that is t tends to 0, and here the function that we got is algebraic function. So whenever we have algebraic function, we apply direct method, and by direct method we try to evaluate the answer. So first of all I'll apply direct method over here. So therefore by direct method we'll substitute the value 0 directly in the t in the function. So here we'll get 1 by 3 plus 0 by 2 plus 0 square by 6. So by direct method I'm getting this term. So if we'll solve this, then 1 by 3 as it is, 0 upon 2 is 0, and here we'll get 0. So we'll get L as 1 upon 3. So the value of given limit is 1 upon 3. Thank you.